So this video is about linear measure. Alright, so first of all, in this video on linear measure, we're referring to finding the length of vertical and horizontal lines. For example, if I had a vertical line from some point like from J to T, it's pretty easy to measure that. Or if I had a horizontal line, let's say this is K to O. It's pretty easy to measure that because we can just count it straight off. Same thing here. If it's a vertical line, we can count it straight off. However that distance is there, that's how long it is. However, if it's a slanted line, it's not quite as simple as that, and that would involve using Pythagorean theorem, making a right triangle, and finding out these two lengths to figure out what this length C would have to be. Alright, so that's in a future video called distance formula. This video is all about finding vertical and horizontal lengths. Alright, so as long as it's vertical or horizontal, it's a very easy way of finding out what those lengths are. Alright, so the first statement says, find the length of segment CE. That means you begin at point C, end at point E. So if I started here at C, I ended there at E. One way we could find that length is we can count it off. We can say, well, this is 1, this is 2, this is 3, this is 4, this is 5, and this is 6. So I know that length there. All right, so from C to E has equal to 6. I can prove it by counting it off. Now, the formula for finding a horizontal length or vertical length, truthfully, is you start at the right and you subtract backwards. So the number on the right is 2, and I will subtract a -4. So 2 subtract a -4, that's a double negative. Mature algebra students say, well, double negative is positive. So that means 2 plus 4, or 6. So we can find it off by counting it, or we can simply start at the right, subtract back. This method is really useful if I had a really long segment and I was afraid to do all the counting because I might get thrown off by trying to keep up with the count to that far or whatever. Or just make better sense. So if I had like 800 here and 7,000 over there, it just makes better sense to start at the right and subtract backwards. Alright, so that's how you find it, whether it's a vertical segment or horizontal segment. If it was a vertical segment though, you don't really have a right. So you'll start at this lowest point and subtract backwards. So let's say this was at on a number line, and this number was 5, and beneath there was -3, right? So if you looked at that, you would start, well, you could start on any end, really. So let's say we start on the top. 5, subtract -3. So if I went here, 5 subtract -3. That would be 5 plus 3, or 8. So I know the length from here to here. This was a number line, a coordinate plane or whatever. Anyway, 1, 2, 3. All right. So anyway, so that was true. I would start here, subtract down. 5 subtract -3 gives me 5 plus 3, or gives me 8. Now you could have counted it off, and you would count it off 8 from here to here. Or you could have started on this end, -3 subtract backwards. If you did start on the bottom end, you would have a different sign on your answer. So you started here, it said -3 subtract +5. Right? So you get -3 subtract 5, you get -8. So because distance should never be negative, we just take the absolute value of our answer. Just make that look a little better. So I'll take the absolute value of -8. And you know the absolute value of -8 is 8. So whenever you got a negative length, it just tells you, oh, I just need to take the absolute value of it. And I get the right answer for it. It should be +8. So let's say I find the length, if I had whole numbers on a number line and so forth, of a segment there. Let me give you another one like that. Alright, so this is a new example. Alright, if you think you're ready to go, pause the video and try without my help. But the question is, find the length of each segment. And this is one segment, this is a different segment, this is another segment, and this is another segment. So the first segment is CG. So again, if you understand it, we'll pause the video right now and then come back and see if your answer matches mine. Right now, give it a shot. If you don't understand, stay with me. So if I were going to find CG, I want to go from C to G. So if I start at the right, subtract it backwards. CG should equal to 8, subtract a negative 4. So that means 8 plus 4. So that should be 12. Did the math right, I know CG has equal to 12. The length from C to G has to be 12. All right, if I try the next one, from D to G, so D is here, and G is there, so it's 8 subtract 0. Well, that's pretty easy. That's 8. So no, DG has to be 8. All right, then if I checked out AE, AE starts here. If you notice, this is negative 8, and that's negative 10, so that's negative 9. All right, and E is here. That's at 2. So I want to go from 2 and then subtract a negative 9. So that means 2 plus 9, or 11. So I know that length has to be 11. And the last one is from A to G. So this is still A, it's still at negative 9. G is here at 8. So it should be 8 subtract a negative 9, which is 8 plus 9, which is 17. So that's how I can find the link for each one of those segments, and that's where those links are. So if you did that on your own, congratulations, you're right. And now let's go forward. All right, new example. All right, the question is, on line MT, point N is in between points M and T. If MN equals 14 and NT equals 28, find the length of MT. All right, a couple important things there. One thing they said was you have a line MN and MT, and point is in between. Point N is in between 2 points. So if I drew a picture of that, I got a line, so I do 2 arrows on the end. That line is named MT. And now I have a line MT. And they said the point N is in between there. So I know N can't be over here, because over here, it wouldn't be in between points M and T. So for that matter, it couldn't be over here either, because then it still wouldn't be in between points M and T. So I know it has to be somewhere in between there. Most students would probably put it right here. All right, but that's kind of misleading because that looks like they're like halfway between there, and that could make you think, well, that's 14 and this is 14. So it throws you off, automatically thinks it's splitting in half. And they didn't say it's split in half. They just said it's in between there. So it didn't have to be at that place. And I wouldn't put it at that place. I wouldn't put it in the middle, directly in the middle, unless it told me it's in the middle. If it didn't tell me it's in the middle, I'll put it someplace not in the middle. And the reason why is I want my graph to, I don't want it to confuse me when I'm trying to find my numbers for it. So, all right, so the first thing they said was that MN is 14. So from M to N is 14. So here's M, here's the N, and that's 14. And then it says that NT is 28. So NT, from N to T is 28. Here to here is 28. All right, so first of all, if this is 14, that's clearly way bigger than that length, and that length should be twice that one. So I already know my graph isn't the scale because that 14 looks bigger than 28. I'm not going to bother changing it though because it doesn't really matter. Unless you just, for some reason, it just bothers you to see it so badly off scale. But what does matter is it says find the length of MT. So you want to find the length from M to T, from here to here. So if I want to find out what that length is, let's think about it. How could you find out the length from M to T, straight across? Well, it looked like it's on a straight line. So because of that, we can just add the lengths up. So if this piece is 14, and that piece is 28, well, M to T equals to the sum of 14 and 28. So that should be 42 units, whatever that unit is, feet, inches, whatever. So I know from M to T has to be 42 units long. And that's how I can find it using the sum of segments. So this is actually called, in geometry, it's called the segment addition postulate. Alright, it's called segment addition postulate because I added one segment and added another segment to equal a larger segment, which is true. Alright, moving on. Alright, this is a note. You can pause the video and get this note written down. But essentially what it says is, if point N is in between points A and B, and all 3 points are collinear, as in line on the same line, then AN plus NB has equal to AB. This is always true. And this fact deals with betweenness of points. Alright, so the fact deals with the geometry phrase or term that deals with betweenness of points. So basically, if I got points on the same line, A and B, and N is somewhere between there, then AN plus NB has to equal to AB. So this piece plus that piece has to equal to the sum of those two pieces. So that's the truth that we use in geometry. It's a clue to be useful in future problems. All right, I hope you got this copied down. I'm about to erase this screen. If you're not done copying it, pause the video and copy it now. All right, so this example says if JF equals to x plus 1, FK equals to x, and JK equals to 3x subtract 4, find the length of segment JK. So let's use the clues they gave us. They told us first clue, JF is x plus 1. So I know from J to F, this section here is x plus 1. And F is in between these 2 points, and these points are all lying on the same line. All right, and then it said FK, F to K is x. So from F to K is x. And they said also that JK, so from here to here, is 3x subtract 4. So this is what we have. What I know for certain is that F is in between these 2 points. So I know from my last note of in-betweenness that JF plus FK, that's the shorter piece, has equal to the whole segment JK. Now it's great that we know what each of these parts are. So I got a substitution I can make from JF. I know JF has to be the substitution of x plus 1. And I know the FK here has to be a substitution of x. And I know the JK, this whole thing, from here to here, is 3x subtract 4. So now I got an equation that we can solve. All right, so I'm going to combine my like terms. All right, so x plus x is 2x plus 1. All that's on the same side of the equal sign, so I don't have to change any signs. I can add them just like they are. So there's no need to like subtract x, because they're on the same side of the equal sign. Equals to 3x subtract 4. All right, so now I need to move this across the equal sign. So now I need to change it. So I'm going to subtract 2x. So that gives you 1 equals to 1x subtract 4. All right, so rewrite that again. I'm just going to rewrite it over here so I got more space. So I got 1 equals to 1x subtract 4. Add 4. 5 equals to 1x. 1x is standing with x, so 5 equals to x. Now, with that being said, the original problem asks us to find JK. They told us JK. JK is 3x plus 4. 3x subtract 4. Now that I know x, I can substitute that x. X is 5. So JK is 15 subtract 4, or 11. And now I found JK. And that's pretty much all I have.